How do you find an image? If you look at a letter L inside a mirror, why does it come out flipped around and backwards? Real simple idea. How many lines in real life determine a single point? How many lines determine a point? 2. One line, you don't know where it is. You need 2 lines. That's why you have how many eyes? You have 2, because you look weird with one eye, right? No, you need 2 eyes to triangulate a single point in space. So let's say we want to find the tip of this L right here. What you got to do is just draw 2 rays of light coming from that L, 1 for each eye. When the rays reflect, they go to your eyeball. Now notice the 2 reflected rays over here. This is eyeball number 1. This is eyeball number 2. Do they cross? Do they come together? Do they converge? Or do they spread out? Which one? Are they coming together? Not at all, right? This is called diverging rays. They spread out. So here's a little trick. In real life, your brain thinks that light always travels in a straight line. So you have to extend the reflected rays backwards behind the mirror. And because there is no light behind the mirror, make them dotted. Those are called virtual rays. Virtual means that they don't really exist. They appear to be coming from behind the mirror. So in other words, when you wake up in the morning and you look into the mirror in your bathroom and you're looking at your mirror image, it'd be kind of freaky if, one day you could step into that mirror, right? Or you chase the white rabbit back there. Your brain thinks that the tip of the L is coming from back there. That's your virtual image. So in real life, the reason why you always see yourself inside a mirror the same distance away is because of reflectional symmetry. Whatever angle of light that hits the mirror is incident is the same angle that it leaves at. So because there's reflectional symmetry, you end up with a virtual image behind the mirror the same distance away. So if you are 2 feet away from a mirror, how far behind the mirror is your mirror image? It's also what? It's also 2 feet away, right? If you are 5 feet away, it's also what? 5 feet away. So to wrap this up here, let's just go over the conclusion really quick. How do we know that an image is virtual, not real, inside a plane mirror? Image is virtual if there is no real light behind that mirror. The rays actually spread out from a mirror, but your brain puts it together behind the mirror. So in other words, when you look in the mirror in the morning, don't rip it off the wall to try to find everyone back there. There is no planet beyond the looking glass, unless your name is Lewis Carroll and you're writing something about this girl named Alice and smoking weird stuff you shouldn't be smoking. Very bad. Next, final question. How is a reflected image different from the real image? Again, your mirror image is not the same as you. If you hold up your left hand, your mirror image holds up its what? Right hand, right? And your left hand is not your right hand. There's reflectional symmetry, but you can't cut off your hands and switch them. That's gross, right? You can't put a left glove on a right glove. It doesn't work, right? So all it is it's your image flipped 180 degrees front to back because of reflectional symmetry from the surface of the mirror. And the object distance is equal to the image distance because the incident angle is the same as reflected angle. So again, if you want to get in close to the mirror and you're only a foot away from the mirror, your mirror image is a foot away. And if you're 5 feet away from the mirror, your mirror image is 5 feet away from the mirror also. So in real life, an architect or designer, they'll use mirrors inside a closet or a small restaurant to give it an illusion of space.
So in conclusion, mirrors are things we take for granted, but if we take the time to study their properties, we can see how they form magic images.